As I was introduced, my name is Jakub Valenta. I come from a company called Accenture. I've been working in IT for actually a long time by now, some 16 years or so. I've been working originally for a company called GE Healthcare, and then I moved to Accenture in 2007, and I am there ever since. In Accenture, I've been working primarily in financial services for a range of clients. I've done sort of my history for to introduce myself. This is actually one thing which I like really on Accenture, that I can work for a lot of different clients, get a lot of experiences. A part of financial services, I've been working also in telco and shortly also in ČD Cargo. My specialization within Accenture is basically technical architecture, so I'm not too much business guy. I understood most of you are business. I'm more the technical guy, but I hope we will find a sort of common language anyway. And regarding Accenture, I don't want to do much of a sort of promo here, but just shortly, Accenture, we are a huge company having over 450,000 employees globally. When I was starting, we had 180,000, so we have sort of doubled, tripled over the course of 10 years. In Czech Republic, about 2,000 people work for us in different parts of in different businesses. I think what could be important for you, we are organizing something what is called Open Slava. That's for those of you who are technical, that's annual conference focused on emerging technologies. It actually just has been in September, October, so next year I highly recommend. I think it's very nice, and it's the biggest conference of its kind in Central Europe. But anyway, this is not why we are here. So I would like to speak about software delivery lifecycle. Please, if you have any question, just do not hesitate, raise your hand or just ask me. If I will know, I will tell you. If I will not know, I will make something up. So let's see if you can tell the difference. But ask me as much as you can. At the end of the day, this is for you. It's not for me to present something, but for you to get some value out of that. So do not hesitate. Ask me at any moment. Of course, I hope we will have time at the end for questions. But if you will have question to some particular slide or some sort of question comes to your mind, just interrupt me and ask me. So in the first part of the session, I would like to basically go through the very sort of basic understanding of what software delivery lifecycle is. It has sort of 4 phases or 4 steps. A little bit describe what you do there. Then I would like to, in the second phase or second part of the presentation, a little bit extend it, because the basic sort of 4 steps are not enough in most of the arrangements. And at the end, I would like to mention a couple of sort of collaborative or agile approaches which are sort of being adopted currently by the industry, and how they are impacting the way we are delivering software. And of course, at the end, if you have time, I will share some stories from real life. So. Software delivery lifecycle. I think if you will go to or Google for it or go to Wikipedia or whatever, you will most probably find that there are sort of 4 phases, right? You have to analyze the problem. You have to understand what the problem is. Do I actually have a problem which I need to solve in the first place? Once you understand the problem, you have to design the solution. Makes sense. Once you have designed the solution, you have to build it, and then you should do some testing to validate that the solution actually works. So those are the sort of 4 basic phases of software delivery lifecycle. I guess you are mostly, or at least those of you who are more technical, aware of that. In the individual phases, what you do. In the analysis phase, as I said before, it's about understanding what the problem is. What do I try to solve? Actually, the sort of key question what you should ask is it actually a problem? Do I have to even solve it? Or am I just wasting time solving something what is not problem at all in the first place? So you should, in order to really understand, you should understand the needs or the requirements of the client or whoever came to you to actually solve the problem. You should understand definitely the the context in which you are solving it. So what are the business processes? What are the use cases? Because typically, if you are designing software, it will be used in some business process which has probably some manual steps. Probably the business process is supported by some other application. So you should really understand the whole context in order to design your solution so that it will fit to the need, that you will not design something what is colliding with some other solution already or in place or the like. The other thing which I do believe is necessary, and actually it's quite often overlooked, and I think it's sort of source of many troubles later on, is something what is called creating or domain model. And I'm sorry for that one. Sorry. Domain model is about understanding what are the relationship between core entities you are handling. Say you are, as I said, I'm from financial services, so say you are designing solution for let's say for providing loans. So you should understand that there is some entity which is called customer, there is probably some entity which is called contract. You should understand what is the relationship of those entities. You should, for example, ask question, what is a person who applies for the contract but never gets it? Is it a customer? Well, technically it's not, because it didn't get really a product from me. So how do I model it? What is the relationship of sort of entry in my system, which I call customer, and the physical person in the real life? Do I have just one entry of customer for every physical person, or can I have multiple entries and the like? So it's typically not big, the domain model. There is just a couple of entities. But it's, I would highly recommend to draw this and really clarify the relationship between each and every entity. You will see in real life when you start to discuss with the business that actually different people have different opinions. Each of them has different understanding, and that clarifying this really helps to sort of equalize the sort of playing field, or to make sure that all of you speak the same language. Other things which you should do rather early is to think about how you will test the solution. You might think, why on earth should I bother in the analysis phase about something like testing? Testing is far away, right? And it is in a way, but if you don't do that, you might run into problems when you start to testing the solution, because sometimes you will find out that in order to test the solution properly, you have to implement something special into the solution. So actually this is one source of your requirements. It's requirements which clients will not give you, but which you definitely need. Once again, if I use an example from financial services, say you are basically, anytime you are dealing with system which counts money or does something with money, you have to often deal with accounting. So you have to deal with things like end of the day processing, end of the month processing, and end of year processing. And those things are rather complicated, and they really have to be done right, because if you are in bank, you do end of the year processing or end of the month processing, and based on that you are submitting reports to central bank. You really want those to be correct. And then you are in the test phase. You cannot really wait for the end of month to simulate the end of month processing. You want to be able to run it every day or several times per day. So you have to be able to sort of convince your system to run end-of-month processing at any given moment, not just once per month, as it will do in production. So those are the kind of requirements which you should identify rather early, as you will want to incorporate them into the design. And if you don't do that, and you will have to wait for end of every month to test the end-of-month processing, and you will need to do it 5 times, say, before you find all the bugs. You will spend 5 months testing, and nobody will be really happy. And then the last thing, which I'm pointing out here, is define architecture. I think definitely that would be on typical projects my role, sort of to have some guy who will draw the boxes and the line between boxes, how your solution which you are designing fits into the complete landscape of other applications you have. Because, for example, in a bank or any other client we go to, typically has tens or hundreds of applications, and you are building one single piece, and it has to integrate well with all the other applications within the client's portfolio. So, when you do all this, you sort of understand what problem you are solving. And the next step is to design the solution. Here are some things which you have to consider when you are designing the solution. The easy part is to design the user interface, right? Everybody understands. I have some screen. It's not really difficult. Everybody can speak about how a screen should look like. Of course, at the end of the day, it's not so simple. You should make sure that there is some sort of customer experience defined. Typically, the customers will tell you, okay, there must be the colors of or our company colors used, and we have some sort of special widgets which you have to use. So you are sort of bound by what the customer wants. But at the end of the day, you should focus on the end-to-end customer experience. It's important, especially nowadays, when people are sort of used to Apple products and Facebook and all those applications which are rather, I would say, slick. So you cannot anymore provide application which works but it's ugly, right? So you have to think about what the customer experience is. Will the customer like to use it, or will the customer decide after using it for 5 minutes that he doesn't want to use it anymore? A part of the user interface, of course, you have to define the business logic, so the services. Some of them might, or the services, they might encapsulate business logic, but also some technical services are necessary, so all that must be designed. And a part of that, of course, you have to handle integration. That's especially on projects like Accenture is participating on. This is always big part. We typically work for large clients. We prefer to do sort of big projects, complex projects, and you might easily be in a situation where you have to integrate to tens or hundreds of applications, and it can be really, really difficult. Very often on the client side is actually nobody who really knows how those applications work anymore, because they have been built 10 years ago, and everybody who knew how those applications work left, or whatever else happened to them. So the integration part is very important, and this might really kill you, because it doesn't matter how well you engineer your solution, if it doesn't play well with 20 other applications or 50 other applications, it doesn't provide really the end-to-end experience or end-to-end functionality. And who cares that your programmers did the job right? If you are sort of unlucky, I would say, then you might need to do something what is called data conversion. So that's basically migrate data maybe from old solution to new solution. This itself is basically, we could have presentation just about that, because that in many cases are a project on its own. When you need to do complex data migration, it might take very many thousands of man days just to make sure that you extract the data from legacy system or from old systems and move them to the new systems correctly. So be aware when this is the situation you will face, that it's potentially very problematic. Because of course if you have to migrate data from legacy system or from old system, you will find out that very often the data there have very poor quality because somebody was manipulating them directly through some database updates or inserts, and it's next to impossible to really extract and transform them using automatic scripts. And last but not least is of course security. So you have to design all the aspects of security. That makes sense. You have from things like making sure that you know what are the user roles, what are the permissions. You should take care about of course some technical aspects of the migration. Of the security. So using the proper certificates, encrypting data, and so on. So security is of course something what you should really incorporate throughout your design. Then comes the easy part. After you have designed the solution, then all you have to do is just to build it, right? So this is the work for the programmers. If they are good programmers, they will do unit testing as well, so to make sure that the solution works at least on the unit level. And once you have built a solution, you have to just validate that everything works. So you have to do the functional test, because you have there the sort of really the individual functionalities which must be validated. You have to do the integration test to make sure that your solution not only works by itself, but works when you plug it in with all the other applications. But it's not the whole story. You have to do also testing on the something what I call here operational readiness testing, and this is making sure that the solution is providing necessary performance. So we have to do performance testing I have separate, but operational readiness is that it provides, for example, high availability, because typically client, I don't know, when you are building internet banking, the clients want to make sure that the solution runs even if one server goes down, right? So the solution must be deployed on several servers, must be done so that when one server burns, that the solution is able to operate. You should typically test disaster recovery. That's a situation most of the clients will have more than one data center. When one data center burns down or there is an earthquake, you have to be able to migrate the operation to the other data center. For example, in banking, in banking, this is even mandatory. The Czech central bank actually says that the banks must have 2 data centers and must do once a year actually test that they are able to switch from the primary data center to the secondary data center or to the disaster recovery data center, to make sure that they are able to operate when something bad happens to their primary data center. You should also do tests like that you can back up your data and ideally also restore. Sometimes happen to the clients that they are able to back up the data, but when you ask them to restore it, they don't know really how. It's why do you back up in the first place, right? Doesn't make much sense. You should test things like monitoring, because if you are running the solution in production, it's very nice, but if you have no idea what is happening with the solution, then it's a little bit risky. So you should integrate it with the monitoring which you have, and make sure that the solution or the proper alarms are triggered when something goes wrong. Then the performance testing also makes sense. You should make sure that the solution is able to cope with the expected load, because it's of no use when the solution is able to handle 30 users when you need to handle it 30,000 users. So you should simulate the load and make sure that it handles that. For that, of course, you have to agree with the client what the load is. We have just had the Black Friday. So, for example, when I was working for a client in US, that's sort of the big thing, the Black Friday, because the load is very, very high, or the number of customers is extreme. So basically, they will tell you how many customers or how many transactions they are expecting for Black Friday. and you have to validate that your solution works even for those conditions, which might be several times higher than the average day. And once again, security. At the end of the day, you have to make sure, or you want to make sure that that the bad guys cannot get into your system. So you typically do something like penetration testing. I would highly recommend that the penetration testing is done by somebody else than the application development itself, because in my mind, it's not good if when the company or the vendor which provides the application does also the security testing. It's so sensitive that it's always better if somebody else has a look on it. So even so, for example, to our clients, we are recommending that when we are building the solution, that that somebody else executes a penetration test, even though it's sort of getting rid of part of the business. But it's just best practice to make sure that somebody else does it. Okay. And that's super easy, right? So this is the software delivery life cycle. What is there something more? Should we bother about something more? And I guess that we all understand that we could, or we should. And in real life, there is much more things which you have to address in order to really be able to deliver a solution, right? There are the sort of set things like taking care about the money. At the end of the day, most of us will do it for money, not just for pleasure. It's sad, but it's true. So you have to take care about the financials. You should develop business case for your solution, right? Because why do you build the system in the first place? It's probably because you want some benefits out of that. When you have the financials, you have to do the, I would say, in a way boring part, but it's the planning and management. It's not as cool as coding the solution or designing the solution or trying to break the solution through test. But unless you do it, it tends to end badly. I would say the rule of thumb is if you cannot plan it, you cannot deliver it. I sort of don't like when my colleagues sort of think that to put the plan together, it's so difficult, but to build a solution, it's much easier. No, it's not. If you cannot put together sort of meaningful plan, then you will never be able to deliver the solution at the end of the day. You should think about things like delivery model. When you are building solution, will you build it with your own internal team? Will you hire somebody? Will you hire somebody or single vendor or multiple vendors? Things like that are important because it will, of course, then impact your costs. You should also think about getting the resources, because it's good if you get the money to build a solution, but are you able to get the people? So is your vendor able to get the people in time there? Are you able to get your internal people available for the projects, or are they busy with something else? You should also think about what happens once you sort of build and test the solution, because then you will have to probably deploy it to production. You will have to prepare the organization for using it, maybe train the users, train the guys which will be operating the solution, and so on. And once you deploy it to the production, you will have to think about, okay, and now what? I have to maintain the solution maybe for the next, I don't know, 5 to 10 years. So how do I do that? Do I have internally people? Do I need somebody else? So, in order to do that, the delivery model can be, or the methodology, delivery methodology, is a little bit more complex. Here it's a picture from actually Accenture delivery methodology, but there are many different methodologies. This is I'm putting Accenture picture because I'm from Accenture, but this is not the only one, not the only right one. So you might see some other as well, and I'm just using this one because that's something what I'm used to. So we have seen some parts of that, right? We have seen the analyze, design, build, test phases of the application itself. So that's we have been discussing, but the other parts, which what they are hiding. So the first step is solution planning. Actually, in Accenture, this is, and it really depends if you are sort of vendor like Accenture, which is providing the solution to clients, or you are a client. The perspective is then a little bit different, or might be very different. But for Accenture, the solution planning, it would be typically our clients will send us something what is called RFP. It means request for proposal. So clients will tell, we want to build internet banking. Please give us a quote, how much it will cost, when it will be ready. Well, so when this happens, we do through something what we call solution planning phase internally. We are trying to understand the scope. Of course, if you don't understand the scope, you don't know what you are delivering. So client will typically provide in RFP some set of requirements. Then, of course, we have some our past experience, so we will incorporate that, and we will sort of define the scope which we plan to deliver. Business case, this is something what typically client does himself, so we don't care in the moment we are or when we are responding to the RFP from the client, in a sense that we would be calculating the business case. Of course, we care in a sense that we have to make the solution reasonably priced, in a sense that it meets the expectation from the client. Because if the client knows that the savings are something, but we propose solution which costs the client much more than the savings, then probably the client will not buy it or will not buy it from us. We care, of course, about the delivery model. Since we are a big company, as I was showing you, we have over 400,000 people in very many countries. So for us, it's sort of important. Do we want to deliver it locally? Do we want to involve our colleagues in India or Slovakia or Romania or wherever? Do we need to bring some colleagues maybe from UK or from US, which might have some experiences which we are missing locally? So we have to think how we will deliver the solution. We have to prepare the plan. You have to understand the key milestone. You have to understand also if there are some dependencies, especially in the large projects. They are happening at the same time when the company is running many other things. So you will have a lot of other dependencies. Your project or your program must sort of align with them. It might be actually bloody difficult to make sure that the changes which you are doing in the systems are actually aligned with all the other changes in other systems done in parallel running projects. But it's necessary to know about that. Right, and then before you start, you have to make sure that you have the people on board, so you come to the client with the team already, and not just with the PowerPoints, with the CVs of non-existing people. Okay. The project management part also very important. I don't know if some of you want to then play the role of project managers or not. I would highly recommend, if you want, I would highly recommend you to first get into some sort of hands-on, be a developer first, be a tester, be a designer first, because I think it's always more helpful to, if you grow to the management role from the position of somebody who was sort of doing the stuff, rather than just becoming immediately somebody who is supposed to manage the stuff and tell other people how to do things. Because the people will quickly realize that you actually don't know how it works or how it is done. And then they will be able to play you a little and tell you things which are not necessarily true. So if you want to do project management, I very much recommend first to really do the stuff. But as a project or program manager, you will have a a lot of responsibilities. You will be preparing a lot of documents, a lot of Excel sheets, and a lot of PowerPoints. Probably the most important thing is really keeping a good relationship with the key stakeholders, with the client, with the leadership, because at the end of the day, those are the people which are approving your budget. Those are the people which sort of pay your bills. So you have to make sure that you understand what is the motivation of those people, what they want, that you are aligned, or the solution which you are delivering is in line with their objectives. Of course, their objectives might change through course of time. So even though you start a project well aligned, 2-3 months down the road, the people might have a little bit different objectives, and you should always check that you are doing what they expect, just to avoid any surprises then when you deliver or when you finish the project and you would like to deploy it to production. To make sure that the people are, or the stakeholders are aligned, you will have to do reporting, and related to this is of course planning. So, you know, I don't have any example of status report here, but of course, in my experience, a lot of status reports show a lot of things with the exception of the status of the project. So always make sure that the status is basically at the end something what should tell this is where we were supposed to be and this is where we are. Are we on track? Are we late? Are we ahead? This is, if the project doesn't show this, it's sort of useless. So it's useless to tell that you have done those 5 components if you don't know if the correct status should be those 5 or some different 6 or something else. So make sure that the status shows really where you are against the plan which you have in place. You will have to keep the business case updated, because of course throughout the project a lot of things will happen. Some of the assumptions which you had initially might not be true anymore. Market conditions might change, and at the end of the day, those changes might be so dramatic that the business case doesn't hold anymore. So you should know it. You should know if it still makes sense, if it's still valuable actually to do the thing which you are doing, because you might find out that actually maybe market changed so significantly that it doesn't make sense to do the project anymore, and that the best thing is to cancel it. It happens. It happens even for projects which are almost ready. Simply, it's not good enough or not reasonable enough to invest anymore to them, and the only good thing or only correct thing is to kill the project. So be ready for that. Make sure that you have the numbers right. You will have to do contract management. So and it doesn't matter if you are on a side of a vendor which is delivering solution for client, or if you are on a side of client sort of buying the solution from vendor. You should always sort of understand what the contract says to make sure that you are always sort of within the range of the contractual responsibilities. So sometimes it's a little bit difficult to understand everything what is written in the contract. They tend to be sort of long and not really nice readings, but as a project manager you will have to understand what it means, and check every now and then that you are delivering according to the contractual obligations. And of course you have to track risks and issues. That's probably a no-brainer. And not just that you track it, because that's the easy part. You should always know what is the mitigation. You should know if there is any contingency in place. So it's not good enough that you know that there is some risk or that there is some issue, but you as a project manager should always know, okay, and what am I going to do about that? In some cases you might find out that actually you cannot do anything. In those cases you have to just sort of escalate it to somebody who is above you and who has more power and more decision-making strength. But most of the time you should be able to define the mitigation plan by yourself, or mitigation actions by yourself. Other thing, and this is my field, is a part of building the solution. You should always define the architecture. So for the technical people in the audience, in short, there are actually 3 different kinds of architecture you should care about. So the first thing is the development architecture. So what version control tools am I using? How am I doing the daily builds? Do I have any automation? Maybe what IDE I'm using to develop the software. So those kind of things that the developers can actually start doing their job. Then there is operation architecture, and that means, okay, how do I make sure that the solution is or can be then operated when I develop it? So this is how do I connect it to monitoring? How do I make sure that the solution scales well? So when there is higher demand for or higher load, higher number of users, that the solution doesn't just break, but it can actually cope with the extended load or extra load. And then the sort of execution architecture, that's I would say the architecture as most people understand it. This is the architecture of the application itself. So how does the application looks internally? What components, what module it has, how it is designed that it works according to the requirements. Then change enablement. This is a sort of word which it took me quite some time to understand what is meant by change enablement. But it's, in a way, it's super easy. If you are doing some new solution, especially if it's sort of bigger or more complex, then you must make sure that you enable the organization to actually absorb the change. Because say you are developing new, say, branch software for the bank. So the bank has hundreds of branches, thousands of people working on those branches, and at one day you will change the software they are using every single day to serve their customers. So maybe if you don't train them, they will not be able to do their job. So that's one thing. Maybe you are actually doing the change so dramatic that it's not just new software and they need new training, but maybe you are changing also the processes. You are maybe changing their job descriptions. You are maybe really transforming the organization, and unless you prepare the organization for the change, it's basically guaranteed to fail. So it doesn't matter. The solution might be perfect. It might do exactly what it should do. It might perform well. It might be secure. It might be everything. It might be good looking, whatever. But if you do not prepare the organization for the change which is coming, the storm will then kill you, because the people will always like the old solution which they understood, they were able to operate, and doesn't matter how good your solution is. So do not underestimate this part of the of the delivery. Make sure that you prepare the organization well. In some cases, this might be extremely tricky, because you might need to train really tens of thousands of people in some situations. That's not very easy how to do it. So it must be planned well in advance. You typically need to have some training materials, training environments, and really organize it month in advance to get all the people which need the training to be trained. And in the same way, like when you are preparing basically the business users, you must be also able to prepare the IT part of the organization for introducing new service. So making sure that the guys which are taking of the running the IT systems, that they understand what it means, the new application, that they are able to actually operate it. That when something happens, they will know how to respond, what sort of processes, procedures are in place, because otherwise the first thing goes bad, and they will not be able to sort of heal the solution, and the customer experience will be very bad. So you have to prepare the business, you have to prepare the IT as well, in order for the solution to be well accepted and well operated. And then service delivery, that's basically the part when you have deployed a solution, it works, all is nice, but you have to think, okay, how am I going to maintain it, because it's good that I have finished the project, I have deployed the solution very well, probably I get paid, or I pay the vendor if I'm the customer, and what's next? I still have to keep the solution running for next 5-10 years, whatever. So I have to have some team, maybe internally, maybe subcontractor team to take care about the application. The same holds for infrastructure. Maybe I don't want to operate the infrastructure, I'm lazy, or I don't have the necessary skills, so how do I take care about it? And in some situation, you of course might be even in a position that maybe you don't want to do the business part of the equation, that you want somebody really to take care not just about the IT part of the solution, but actually even do the processes that you want outsource the business processes which are done through the application. So you have to prepare for that, have a plan for that as well, in order to have successful delivery. Okay, this is a. I will once again show you the big picture. So this was to show the whole process for software delivery lifecycle. So from the solution planning, when you are understanding the scope, doing the business case, doing or deciding the delivery model, through the project and program management, so making sure that you are aligned with your stakeholders, reporting to them, updating the business case, taking care about the architecture of the solution, so the development architecture, operations architecture, execution architectures, over the change enablement, preparing the organization for the change, so training the users, preparing the training materials, executing the training, and so on, making sure that the business processes are set up reflecting the new solution, making sure that the KPIs are aligned with the new solution, because the people might be paid according to meeting the KPIs, so you have to make sure that the KPIs still make sense. And the service introduction, preparing also the IT part of organization, and then when you deploy the service delivery, so making sure that somebody has there is somebody to operate the solution properly. Everything clear? No questions. Very good. I'm very happy that you are either totally bored or I'm clearer than ever. So I have to make up my mind. What is it? But let's see. Okay. In the last module, what I would like to speak is basically three trends which are now, I don't want to say emerging, because some of them are sort of mainstream nowadays, like the agile development, but there are sort of approaches which are affecting the way how we deliver software or how we deliver systems nowadays. First thing is design thinking. Is here somebody who knows what design thinking is? Nobody. Is here somebody who does not know what design thinking is? And the rest doesn't listen to me. Okay, but thank you for those of you who sort of raised the hand. Okay, that means like 95% of people is asleep basically, but okay. Well, design thinking is first of all, I would recommend if maybe to spend then some time and just a little bit Google for it, because this is something what is, I think, emerging in the last, say, 2 years as an approach how to drive innovation in a way, and it's something what is really sort of forcing the people to focus on the real problem. So even if you think you are doing a software project, at the end of the day you are not doing software projects to deliver software, but to solve some human need. Most typically, of course, you might do some software because of software, but typically you are solving something what people need. So really to understand what is the problem of the people which you are trying to solve, not to jump to the fact that you are you are engineering some technical solution. No, you are not. It's about doing solution of a people's problem. So really understand the human aspect. The idea is that that you should sort of creative and playful. The idea is that you try to solve the solution or find the solution in I would say set of games, but it's not really game, but together with the collaborative approach. It's basically about getting together a bunch of people. Actually, it should be rather diverse set of people. So it's not like okay, I'm doing this application for branch or for the clerks in the branch of banks. So I will get 2 or 3 of them and ask them, but really have a range of people representing all different kinds of background and ask them and work together. You typically would involve really not just people with different background, but of also different levels of seniority. So it's not just really having the very senior guys which should know everything best and having them to decide, but you will have really from junior people to very senior people working together to trying to find solution, and basically they should work in a sense as being equal. So there is not one idea is not better than the other. They have all the same boat. Of course, in order to it's iterative in a sense that you cannot come up with the solution or with the best solution in a single step. So you will do couple of iterations, and typically you do prototypes. So when I take, for example, in Accenture, we are solving this so that we have something what is called liquid studios. We have tens of them around the world. The closest to us is in Bratislava, and we will invite our clients for say 1 week session when they will I don't know, maybe 10-20 people from client will sit from people from our side. We have our developers there with experience in different kinds of technology, and they will really work together. They will try to find to generate the ideas, generate the prototypes, see it, how it works, and so on. You might do the prototype not just by coding. You might do the prototype but just by sort of I don't know, sticking some cardboard boxes together. It doesn't really matter, but you should have something what you can experience and play with. So this is really it's really designed sort of to break the barriers, sort of make the people through, I will say playing, but really come up with very innovative or very, very out of the box ideas, so to speak. Sort of really thinking out the box, making sure that you have the phases where when any idea is okay, you don't judge, you just throw the ideas, write them or on some sticky notes, put them on the whiteboard. You just want to generate all kinds of ideas, and only then you will do the selections, right? So I think design thinking, as I said, check it. I think it's worth at least to know that it exists and what is it about. I believe, for example, Microsoft has some free trainings available. So if you will check, you can get online trainings from Microsoft for free. Yeah, the design thinking itself, it has couple of phases. So it has discovery phase, describe phase, and then you are ideating, prototyping, and testing the solution. So this is design thinking in short. So it's basically design thinking is addressing the part of delivery when you are from really the planning or creating the ideas to the design part. So it's not about really necessarily developing it, or you are developing just the prototype, but it's this part when you want to find when you want to really understand what is the problem, what the solution should be, create as many ideas and select the best idea out of that. So it's sort of different from the, I would say, traditional approach when somebody from client side will be asked to take an Excel sheet and write 250 requirements which will be sent to the vendor. So this is very different. It's about collaborating, typically vendor and the client, finding out what the solution should look like. Then the other thing is agile development. I'll ask anybody who knows what agile development is. Okay. Anybody knows what Scrum is? Okay, good. Well, I would say it's actually nothing new in a sense that agile methodologies have been with us, I would say, 20 years basically. So in that sense, it's not new. Basically, when I was starting back in 2002, there was something what was called extreme programming, sort of generating a lot of hype. I think meanwhile it was replaced by Scrum, or Scrum is the agile methodology nowadays. And of course, if you look outside of the software engineering, you will look into industry like automotive, when Toyota introduced back in 50s, 60s something what is called Toyota production systems, and they were already at that time looking at how to be lean, how to make sure that you are not doing useless stuff, and they were asking their employees how to really improve actually the way they make cars. So software development sort of caught up 4 years later with the agile development methodologies. The difference is that the traditional software development methodology, it's called waterfall. It's basically you have the phases. You do 2 months, you do analysis, 2 months or something, you do design, then you do a couple of months coding, then you do a couple of months testing, and after 9 months you are, or something like this, you are able to deploy to production. And of course some people say, yeah, why I should wait for my features 9 months, I don't like it, that doesn't make any sense, I want the features tomorrow, right? That's what the business people would say, why should I wait 9 months, why not tomorrow? So agile development methodology is something about shortening the time to market. So it's about doing things in something what is called sprint, that the sprint typically lasts from 1 to 4 weeks. And you will, at the end of each sprint, you should be able to deliver to business some value. It's of course much smaller value than you are able to do in 9 months, but you should be able to deliver little by little, but with much higher frequency. Okay, when you are running agile project, before you start to run in the sprints or the iterations, you typically have something what is called sprint 0, when you are doing a little bit of planning, and because before you start to run in the sprints, it's better to do things like really understand or establish the vision, to understand what you are actually doing, where are you running before you start to run, and things like this. So sprint 0 actually surprisingly often ignored, and it's sort of, let's get to coding, right? Let's start running, but where should we run? We don't know. No, it doesn't matter. Let's run. So I would recommend not to underestimate the planning even in agile methodologies. Actually, just like 2 weeks ago, I was on one workshop we had internally, and there were colleagues of mine. They were sharing experience when they were doing some work for large logistic company which was operating in Europe and which was operating across Europe, and they had actually businesses in very many countries here in European countries, and they basically were created by acquisitions. So every single country was sort of different kind of mess. And at one point they decided, okay, every single country has its own system. It doesn't really work together. When we want to ship parcel from one European country to another European country, it's hell on earth, because the systems sort of do not communicate. So they asked us to do to help them and to sort of deliver some unified architecture, unified portfolio, application portfolio. And then they decided to do it in agile way, but agile way in a sense when the when the first sprint took half a year. So it would be for most of people, it would be like, okay, sprints are typically like 2 weeks long, not half a year long. But it actually made sense because to define architecture for something as complex as was this client really cannot be done in 2 weeks. So you have to do really a lot of thinking, a lot of investigation, understanding all the applications which they had, understanding which applications should be kept, which should be kicked out, which should be sort of further developed, and so on. So in agile development, the sprint can be sometimes long. And then when you do start the sprints, as I said, the sprints are typically 1 to 2 or 2 weeks, might be 1 week, might be 3-4 weeks. And within the sprint, you should do basically everything. You should design the thing, you should build the thing, you should test the thing. So the things must be really small in order to manage within the time frame of the sprint. You have something what is called ceremonies. Those are the sort of important meetings which you have. So you have some backlog grooming when you are making sure that, okay, you understand what is in the backlog, what it means. Then you do sprint planning, that you decide what you will include in the sprint. And at the end of every sprint, you do some review, sort of you try to learn from what you have done. Have you screwed up something worked for you well, something didn't work for you, to make sure that the next sprint you don't do the same mistakes. Okay. And of course you have something what is called daily stand-up. Basically, the teams which work in the agile delivery should be typically very small. It should be around 80 people. They should sit together. They should every morning they should meet. It's called stand-up because the goal is that you keep the meeting as short as possible. So if the people don't sit down, they don't tend to talk long because nobody wants to stand for a long time. So the people gather somewhere, and then within 15 minutes or so, they just share the key points which they have, and they go and do the work. Actually, from the real life, I think agile development is one of the most misused, I would say, methodologies like I've ever seen, because basically now what I see is that all the clients want to be agile, right? Because being agile, that sounds like the right thing. Do you want to be agile? Yes, I want. What does it mean to be agile? That's a mean question, because most of the people don't really know what does it mean to be agile. They want to be agile, they don't know what it means, because it's difficult to define it. So what I see when the people speak about agile methodology is that they do the sprint, so they work in 2 weeks iterations, but at the end of the day, they do basically just a waterfall. They do 2 week sprint when they are designing, 2 week sprint when they are building, 2 week sprint when they are testing. And then they repeat it, and maybe once per month or once per quarter they have some release. So, but they can say that they are agile because they have the daily stand-up, they have the 2 weeks iterations or the sprints. What is it good for? I don't fully understand. But this is sadly how agile is sort of implemented in many companies in Czech Republic. I don't know, any of you working on some projects where agile would be used properly? Okay. Any experience you would like to share from? Okay. Okay. But good. If it worked for you, I think it's definitely something what works. Agile as such works. It just must be implemented properly. And my experience is why it's not implemented properly very often is that the organization is not really ready for it culturally, because it's really big change. You have to have the business working with the IT in order to provide very fast feedback, because if you should do something within 2 weeks, then you cannot wait 3 weeks for an answer from the business owner, right? You have to answer. You have to have the answer immediately, the same day, the same hour. And typically the organizations are not ready for this, so the IT is trying there to run the things in sprint, but it's actually sort of just parody on agile in many ways. Anyway, agile development, be sure you know that it exists, that it's sort of run on the sprint, that most of the customers don't know what agility should mean or in which way they want to be agile, sort of what they want to improve. But they turn to agile because they don't measure usually anything. So at the end of the day, they cannot say if introduction of agile helped them to be cheaper or faster or something, because they don't have the metrics or the data. And the most popular methodology for agile nowadays is Scrum. So for those of you which are sort of interested in IT, or I guess all of you are, because you sort of came here. I don't know how many of you had to come here, or how many sort of selected it voluntarily. But Scrum is one of the buzzwords, so that at least you should know what it means. Another thing, or the last sort of movement or methodology or approach which I would like to speak about is something what is called DevOps. And once again, I'll ask, who knows what DevOps is? One hand. Very good. Okay. Anyway, for those of you, for the rest, one of you knows. For the rest, DevOps, as the design thinking was addressing basically the first part of the delivery life cycle, so focusing more on the ideas, on the analysis, on the design. So DevOps is actually more focusing on the other part. So the builds, the testing, the deployments, the maintenance, and the idea is. And actually, in typical organization, and those of you who have ever worked or had a chance to work for some sort of a bigger company will probably know that there is a sort of big gap between the developers and then the poor guys in operations who are running the solution. Those guys who are sort of every single day and night making sure that the solution doesn't break. Because you have the developers which are sort of developing every day, introducing the changes and doing this cool stuff. And then you have the poor guys in the operations which are then responsible for making sure that the solution is running also at 2 in the morning and 4 in the morning, and it doesn't fail despite the developers doing or delivering solution where is a lot of bugs. So there are sort of two different words: developers trying to introduce the change, operation fearing the change, because every change means that it can break. They can get the phone call 2 in the morning that the solution is down, and they are supposed to save it, and they don't know how, because nobody told them how, of course, because there are no manuals, no instructions. So the DevOps is basically trying to sort of fix this bipolarity in the organization, and it's actually typically or in many organizations you will see that what they do is that they will automate, right? The DevOps is actually about automation. So we have here the tools which will do automatic builds, automatic deployments. If we are a very, very fancy company, we will automatically deploy all the way to productions. Maybe we are lucky enough that we have even automated tests. And if we are super cool company, we even measure things about what we are doing. Most of the companies don't do, but we try. But in order to really, actually, in my mind, to reap the benefits of DevOps is to do the cultural change, because unless you have the culture that the organization works as one and that there are no those silos, it will never work. One great example, somebody knows a company called Netflix? Ah, very good. Okay, Netflix is actually a company which is or sort of centered about the culture of individual developers having basically unlimited, I would say, not power, in a sense that every single developer can commit to or can deploy to production. I cannot imagine this for most of our clients, but in a Netflix, the idea is, if you are a developer, you have developed something, you will push it to the production, and if it breaks, you will get the call 3 in the morning and you will go and fix it. After you get a couple of those calls, you will make sure next time that you don't commit to production anything what is broken. And of course, Netflix provides you all the automation which is required for that. So for you as a developer, it's really about writing the code, writing the test, and then the platform which you have available will do it for free. But it's really about the making sure that the organization is ready for those things, not just providing the tooling. I think most of the companies nowadays are happy just with getting the tools, making sure that, okay, I can press the button, the solution will get built, maybe will get deployed to the test environment, and that's it. That's but ideally, you really press the button, it's deployed to production. Actually, if you take companies like Netflix, like AWS or Amazon, like Etsy and the like, they are able to do deployments to productions, actually not on daily basis, but on basis of, I think the Amazon is deploying every like 15 seconds something to production. So it's extremely rapid. Typically organization, the clients I work for, or the companies probably you will work for, are deploying once per month or something. There are companies which are able to deploy every few seconds to production. Okay, and DevOps is the enabler for that. If you are not able to automate everything what is possible to automate, you will never be able to deploy it so quickly. And when you are able to deploy so quickly, you can do a lot of cool stuff, right? You can test what works, what doesn't work. So you can do A/B testing. You can deploy different versions of your application and see how customers or users are interacting with it. What works, what doesn't work. So you have companies like Booking.com that sort of champion in really testing hundreds and hundreds different ways how their site should look like, and testing what actually works, what makes you to book the hotel with them, and what does not. And they are really iterating and testing all the time something new, trying to figure out what will make you book the hotel. I think their conversion rate is like two to three times higher than the rest of the industry, because they are really testing all the time something new, because they can automatically deploy new features to the production and see how they behave. You are not well. First, you can do automatic testing. That's first thing. Second, I think you can of course, even with DevOps, you can integrate the automated the manual testing within that, right? But the idea with this is that typically the changes are actually rather small. For example, a lot of those changes might be just, okay, let's put the button somewhere else. Let's make it a little bit different size. So they don't really require a lot of testing, but actually from the perspective of user, or the impact of if the user will notice the button, will click the button, even a little change might actually drive a significant change in behavior. So they are able to do this with automated testing, because the changes are actually small. And a lot of those companies, if you will look like companies like Amazon and the like, they have just automated tests. They don't have any sort of manual testing, because it would kill them. You cannot test Amazon Web Services manually every now and then, because you would need, like, I don't know, a couple of tens of thousands of poor testers which would be clicking there. So I think they are really betting on the automated testing. Of course, then you have to have also pretty good monitoring in production to see if something is actually failing, that you can really quickly react and fix it. And then again, if you have the DevOps and you are able to deploy the fix pretty fast, then you are sort of safe, because if you find the error quickly, because you have good monitoring, you alert the developer who fix it, and then you can deploy it within a matter of minutes, because whole the pipeline for deployment is automatic.
Sort of software which tests some procedures besides the user or tester.
Yeah, I think they would typically have automated testing. So you have software. Actually, I have here under the test chevron, there are some tools which can be used for automated testing. So you have tools like Selenium or JBehave, which you can plug into the DevOps pipeline, and they will automatically test the software. Of course, you have to write the automated test, so it's again a software, the automated test, so it's software testing software, but can be done, and it is done for many of the companies like Amazon, like Netflix, like Booking.com. They do this primarily automatically, because anything else would kill them. I think it can be website, it can be, but if you are for example Amazon, in sense of cloud, Amazon cloud, not the Amazon.com where you are the eShop, but AWS, Amazon Web Services, then it's not really website. It's super complex cloud provider which is doing basically provisioning infrastructure or the whole data centers for you. So it doesn't have to be just a website, in a sense, web application for end users. It might be something as complicated as AWS. And I would actually say that the website might be a little bit trickier to test, because it's sort of easier to break it. In a sense, if I have a web service, I have some really web service, I don't know, soap call or something. It's sort of I can call it, I can test it. If I have the website, I have to have some application which works as sort of browser against that. This is, for example, the work of the Selenium would do, and which would simulate the web browser for me. So it might be a little bit trickier. But if my test, if I have just a set of APIs which I have to call for my test, that's sort of easier. So I would say to test application which doesn't have front end is actually automatically is easier than to test application which does have front end. If it makes any sense. Okay, and actually this brings me to the end of my presentation. I understood then that we have 12 more minutes. So if you have any questions, it can be to the presentation, it can be unrelated. Just feel free. If you don't have any questions, that's also an option, of course. Sorry, once again?
I just missed the word Scrum. You said, but I didn't see the
Yeah, I think I might not have the word in the presentation itself, but basically, if you will look into this picture, this is basically a picture of Scrum. So you have the Scrum ceremonies, you have their actually daily stand-up, that you have something like Scrum Master, Product Owner. So this is the vocabulary of Scrum, so to speak. So this is Scrum is just one of agile methodologies. It's not the only one, but it's one which is used very often. But I didn't want to sort of go in detail into the Scrum itself. For example, if you will, because Scrum as a methodology is designed for, say, smaller teams. If you are a large organization which has hundreds of developers, then typically Scrum as such doesn't work for you, because it's about you have a team of 8 people, and they are happy. For the large organization, there are methodologies, for example, which is called SAFe. It's Scaled Agile for Enterprise. It's something extension of Scrum. Or you might have sort of Spotify methodology. It's also extension of Scrum, but you have a little bit different things. You have not just teams, but you have some tribes and guilds and the like. This is because the Scrum is really for smaller team. If you want to work in the enterprise environments where you have hundreds of developers, you have to have something bigger. Okay. But no, at the end. So the the idea of Scrum then is that you have small team, ideally sitting together. It should be a multidisciplinary team, so you would have 8 guys which can ideally do the analysis, build and test it. You have there Scrum Master in a sense, and I will now say that he's the team lead, what is actually wrong, because in the Scrum you should have it should be sort of team of equals. It should not be that I am the boss and you are sort of my team members. No, this is one team working together, but the Scrum Master is then somebody who is responsible that the sort of methodology is applied correctly, so that the team really does the daily stand-up, that they do the planning, do the retrospection, that really the team works according to the methodology and basically guards the team against, I don't know, business who wants to, in the middle of the sprint, wants to push in some additional features, because the methodology says at the beginning of sprint, we decide of the scope of the sprint, we deliver it. In between, you cannot halfway through the sprint add any other feature, even it's very important feature. You cannot, because the sprints are simply atomic. So if you decide something what is in the sprint, the only place when you can do change is at the beginning of next sprint. So the Scrum Master is sort of guardian of the process. Well, you can say that, but it's project manager in a way is somebody who is really leading and ordering the team what to do, while in the Scrum team, the team should be more self-organizing. So it's not the Scrum Master who says, now you do this. The ideal team in Scrum, you would have actually rather senior people, and they would not be assigned the task, but they would sort of take the task. It would be, okay, we are team, we have here this task, so, or the set of tasks, which is called backlog. So now in the planning phase, let's say what we will do in the sprint. We will commit to it. Each of us will commit to it, because it's our plan. It's not my plan of Scrum Master, but it's a plan of us as a team. And we will then work together as a team to do it. So it's not. It's really. It's more somebody who is overseeing the process is working fine. It's not somebody who is giving orders to the rest of the team. So this Scrum Master is not the boss of the team. This is actually one of the problems which I see very often, because clients would like to have agile teams, and at the same time would like to have cheap teams, so rather junior teams when the guys don't necessarily know how to work. So they still expect somebody to tell them what to do, to have some project managers. But in the real Scrum, you should not have project manager. It's not there. You have the Scrum Master who is overseeing the process, and you have the business owner who is basically representing the business and saying, okay, are the priorities of the tasks we should do. So this is the guy who says, okay, I have here 200 tasks, they have this priority, so let's do now these 5 most important, or with the highest priority. Okay, so I don't know if it helps anything, but okay. Any other questions? No? Okay, then thanks a lot. I really appreciate your attention.